Hi everyone, I'm PJ, and in this video, we're going to prove that if an infinite series of complex numbers z converges to some s, then the infinite series of the conjugate of z converges to the conjugate of s. Before anything else, we're going to need a theorem in the convergence of series. Suppose that the complex number z sub n is equal to x sub n plus I y sub n, where n is a set of positive integers and the sum s is equal to x plus iy. Then the theorem states that an infinite series of z sub n converges to s if and only if the infinite series of x sub n converges to x and the infinite series of y sub n converges to y. This theorem is important since we can write the infinite series of z sub n as the infinite series of x sub n plus I y sub n, or separately, the infinite series of x sub n plus I times the infinite series of y sub n. Now that we are all set up, let us formally start our proof. In a similar fashion, suppose that an infinite series of complex numbers z converges to a sum s. Let z sub n be equal to x sub n plus I y sub n, and s be equal to x plus I y, where the infinite series of x sub n is equal to x and the infinite series of y sub n is equal to y. From what we have defined, notice that the conjugate of z is equal to x sub n minus I y sub n, the conjugate of s is equal to x minus iy, and the infinite series of negative y sub n is equal to negative y. Here's to the skeptics out there regarding this last note. Observe that the infinite series of y sub n is just equal to y sub 1 plus y sub 2 and so on until infinity, which we can write as y. From this, the infinite series of negative y sub n is just equal to negative y sub 1 minus y sub 2 and so on until infinity. Factor out negative 1 from each term, and this sum is just equal to negative y. Going back, remembering what we have noted, you can see that the infinite series of the conjugate of z can be written as x sub n minus I y sub n. Remember that the theorem we have discussed earlier can make us write this current line into the infinite series of x sub n plus I times the infinite series of negative y sub n. This is just simply equal to x minus iy, which turns out to be the conjugate of s. And thus, we have proven that if an infinite series of complex numbers z converges to some s, then the infinite series of the conjugate of z converges to the conjugate of s. Thank you for listening.